Welcome to Castley Physics. This is our first video, and I'll be continuing to deliver some interesting things in physics in this channel. And this channel is for high school students who really loves physics. Today we're going to talk about how do wings work, and the video is divided into 4 sections because of the time limitation. Actually, the things you have heard about explaining how the wings work is quite straightforward and seems logical. It might seem correct, but if you think deep into it, it will give you some sleepless nights. Indeed, the most widely used explanation is run in a number of points. So we will start with the most popular explanation, and I will give you some alternative way to solve this problem. Okay, let's start. So in the picture is an aerofoil. Aerofoil means the cross-sectional shape of a wing. And as you can see here, point S is called the stagnation point, where the front edge of the aerofoil meets the air. And the curved lines here are called streamlines. The streamline means the path of a particle in a fluid. So as you can see, fluid particles do not travel in straight lines along the surface of the aerofoil. It travels in curved lines. The most popular explanation tells you that the oncoming flow divides into the moving above and below the wing from the stagnation point. So it argues that from stagnation point to the tail of the wing, the particles travel longer distance through the upper surface of the wing than the lower surface of the wing. It's supposed that two neighboring fluid particles splitted at S, stagnation point, and they should meet again at the point at the end of the wing. So let me take this point as T. So what they argues is the particles, they should arrive at T simultaneously as they are split at point S at the same time. So as the distance traveled through the upper surface L1 and the distance traveled through the lower surface L2, L1 is bigger than L2, and the amount of time they traveled is equal. T1 is equal to T2. Hence, they argue that the speed of air through the upper surface is greater than that from the lower surface. And the teachers or textbooks mainly have tell you Bernoulli's equation, which means longer velocities imply lower pressures. Hence, there is a net upward pressure. So there is a force. They argue that pressure here, P1, is smaller than that pressure P2. So there is a net force acting upwards. You can simply demonstrate the so-called Bernoulli's equation by using a piece of paper and your hand. You blow over the piece of paper held between both hands as demonstrated in the picture. As the air is blown along the upper surface of the sheet of paper, it rises, and it is said that it is because the average velocity on the upper surface is greater than that on the lower surface. So you can see the paper rising. Sorry, this one is not the sail, it's just a piece of paper. And this one is your hand, and this sheet is your paper. According to Bernoulli's equation, this would mean that the pressure must be lower above the paper, causing lift. So the above explanation is widely spread, and it can be found in many textbooks. However, there are some mistakes or points that you cannot give a precise explanation, and we will talk about it in the next section.